Used another one of the 2x4 Basics workbench kits that I had, and I just threw together a workbench as quickly as I could. There's the final position of the workbench slash battery shelf. I made it purposely small. I don't want to use up all my floor space, and it's not the kind of workbench I'll be sitting at per se. It's sort of a dual purpose system, and I don't want it pushing out too far into the room and taking up too much space. Unfortunately, the power board pushes it out 3.5 inches into the room, which I don't like. Later on I may change that, but right now I'm just going to keep it the way it is. Now I'm going to clean up the mess that I made and put this thing into service right away. Before continuing, I wanted to show the solar-powered camera light and or work light that I've been using for actually a long time now. It's in a lot of my videos, and I may have mentioned it a few times, but I'm going to go ahead and show how it works. If you look in the upper left-hand corner, you'll see it. It's right there. And it's a 30-watt LED flood lamp, 12 to 24 volts. Of course, the solar panels I'm using to power a lot of this stuff on my power board, there are 12-volt solar panels, and so their open circuit is around 19 volts, 18 volts. And as of right now, they're 18.5 volts, even while running that light directly. Also running all my other equipment and gear, powering fans and whatnot. They're still able to run that light at full brightness. There is no battery or charge controller or anything in between. It's just straight from the solar through a fuse for safety and into that light. There is a better shot of the light. I have it temporarily attached to the ceiling using a work clamp. It's kind of precarious, but that'll do for now. There's a look at the voltage of the solar panels. This is the two 100-watt solar panels that I've had for quite some time now. They've been moved over to the solar workshop and have been powering all of my gear, charging my phones, cameras, any USB gadgets I have, charging solar generators, and of course running my floodlights for working and for recording footage. And even with all this stuff running, it's 18.5 volts, so I can run plenty more stuff. There's a better shot of the solar power equipment board as it stands right now. There's going to be a lot of different upgrades taking place here. I did not record everything. Some of the stuff here has changed, and particularly this wiring here in this area has been redone. And I added this fan controller and the fans, and so I didn't record everything. But now that I have the workbench slash battery shelf, I'm going to go ahead and bring over some gadgets and equipment that I've collected, and going to start pressing them into service. I did want to point out that I bought a better camera tripod. I hope it helps. It's not a super high-end one. It's just better than what I normally have. Usually I use the ones that are $7 or $8. This one was about $30, so it's a little more expensive, but it has a lot of adjustments and I'm still learning how to use it. So there's a view of part of the nice clean workbench area. Might as well clutter it up with a whole bunch of gadgets. After all, that's what workbenches are used for. Okay, here's the first item that I'm going to put on the battery shelf slash workbench. This is actually a really old battery. I've had this many years. This is I've had this at least 10 years or something like that. Probably more than that. I got this back in the day when I first started looking into lithium iron phosphate batteries. The first lithium iron phosphate battery I ever purchased was a little teeny tiny 6-volt battery. It would fit in the palm of your hand. I put it inside of a fluorescent lantern, Coleman lantern I had when I was a kid, replacing the lead acid battery, and it worked extremely well. I then went on to buy this battery here. Unfortunately, this battery, I ran my bedroom off-grid for years, and I really worked this battery very hard. I had it out of service for about 4 or 5 years now. It's dusty, it's dirty, and I really don't know what the state of charge is on it. I have no idea. It's just been sitting. Unfortunately, it was also deep cycled. Made some mistakes. This was my learner battery. This particular battery is a type that is doped with manganese, so it's LiFeMnPO4. I haven't found any difference between the doped batteries and the standard chemistry. For all intents and purposes, it acts just like a normal lithium iron phosphate battery. Might as well get it over with. I'm going to check the state of charge of this battery. So, this is negative on the balance lead, I believe. Yep, this would be your negative point right here. So I'm just going to go ahead and plug it in and see what happens. And got a bad connection here. Actually, it's not too bad. It really isn't too bad. 21 millivolt. Actually, it's at a good storage voltage. But what I'm going to do is use this for my power system out here in the solar workshop for the time being. Here's another view of the battery computer. And actually it has a bad connection, so now it's down 12 millivolt delta. Of course, this is almost meaningless because a lithium iron phosphate battery, really, at rest, it's very hard to tell what the state of charge is. It really is kind of meaningless. But that is the resting voltage of these cells after many, many years of sitting on the floor and getting dust all over it. So it's still useful information. You can see there's not much difference between the cells. Number 4 is a bit high, 3.316 volts. So basically what I need to do is put this battery back into service and cycle it and see how much capacity I can get and just see what happens. I don't know if it's really a 100 amp hour battery. That's what it was when I bought it. But I don't know what it is now after I've abused it. So we'll see. Okay, the next item is, this is kind of a tragedy. This is a very nice solar generator I purchased years ago. I got it for a huge discount. Normally it was quite expensive. This one was deeply discounted, and it has what's called a vacuum fluorescent display. It's a very nice looking display that lights up, and it uses high voltage, and it's really nice looking. I bought it knowing that the VFD display was probably the weak link and would probably fail, and don't you know it, about a week, maybe a week, I don't remember exactly, after I got this thing, the VFD display failed. And what happens is all the segments on the display come on. I don't know if I can get it to do it. No, it doesn't look like it wants to come on. This thing is dead as a doornail and I need to charge it. Yeah, it's dead as a doornail, so I can't do anything with it just yet. So what I did is I tore it apart and I gouged giant holes in the front because everything's glued together and you can't get to the screws. So I had to gouge holes in and pull the screws out. I need to add a charge controller to the board. So this is the next piece of gear. This is a charge controller I've had for quite some time. Just sitting around waiting for me to have a chance to use it. And I have a similar one out in my solar shed. I don't know how it compares to this one. There's multiple models. I don't remember which one. But it's an MPPT charge controller. They work pretty good from what I've seen. And I like them. I think they're very well priced for what they do. This is brand new. It's never been used. And I'm going to see what I can do with this thing. Quick look at the manual. I don't know which version I bought. It doesn't say on the charge controller. There's a 30, 40, 50, and 60 amp. But I do like these things, and the one I have in my shed is works fine. So this one I'm going to use with my lithium iron phosphate battery. Eventually I hope to have a much larger battery bank out here, but I'll start with the 100 amp hour battery that I showed earlier and go from there. I like the mounting solution on these charge controllers. It's kind of unusual. They give you these little mounting brackets, and there's 4 of them, and they go on the side of the controller. So the mounting bracket goes on there like that. Put a screw in. Pretty neat. And I like how you can take them off if you don't want to use them. Another feature I like about this charge controller is they give you double terminal blocks. Everything is twice, so you have 2 places to put a wire for each connection. So you can double up your wires if you want to, and it's pretty handy as well. I rigged up some wires to this charge controller because I want to program the settings and have a look at the settings. So I just put alligator clips with the ends cut off, and I'm going to connect it right now to my 4S lithium iron phosphate battery. .118, that's the firmware version, I do know that. Okay, so it's on. I have a similar charge controller in my solar shed, so I have some familiarity with the programming of this charge controller. And I do like that it's extremely simple. You just press program, and there's only a few settings you can change. 00 is actually the low terminals, and I hope to use these low terminals with my security lighting system. Now, it's supposed to be good for only a few amps, so I can't run high-powered lights, but I don't need to. So my lights will probably use anywhere from 1 to 2 amps, so these low terminals should be able to handle it. Right now I have it set to 10 hours, and I may change that up or down later. And the next setting is D01, and that's the float voltage for the charge controller. In my case, I'm using a 4-cell lithium iron phosphate battery. I do not use an active battery management system. I never have. I do use a battery monitoring system, or BMS, and I do not have a battery protection circuit, or BPC. There's a lot of false and erroneous information on the internet and everywhere about lithium iron phosphate batteries. Even some products and product manuals, a lot of bad information and a lot of bad product design, and I can't do anything about that. But I can openly share the knowledge that I have, and number one on my list is lithium iron phosphate batteries and any lithium ion chemistry should never be float charged. And of course, almost every charge controller has a float setting, but that setting would have to be used with the greatest of care and an abundance of caution, and you really need to know what you're doing. To keep it short, a lithium iron phosphate pack can be destroyed by the float setting on a charge controller. Lithium ion and lithium iron phosphate chemistries are just not suitable for float charging. That's basically outdated knowledge, and it applies to lead acid batteries. Absolutely, lead acid batteries have to be float charged, but a lithium ion or a lithium iron phosphate battery does not need to be float charged and should never be float charged. That having been said, the float setting on a charge controller can be used in different creative ways, and if you're able to program the charge controller correctly, it can still be useful. In this particular case, I'm interested in a safe voltage for my charge controller that I just got out of the box, and I don't want to have an accident and walk away and leave it and accidentally float charge my batteries while I'm developing the system and doing the initial setup. So I want a safe setting to go ahead and program into the float voltage just in case I make a mistake and I don't want it to harm my battery. So what is a safe voltage to use on a 4S lithium iron phosphate battery pack if you have to enable the float mode or you don't have a choice? And the safe answer would be the resting voltage of the battery pack. A super safe answer would be just below the resting voltage of the battery pack. Lithium iron phosphate batteries in a 4-cell configuration will generally rest around 13.3 or 13.36 volts. So 13.3 volts could be considered a safe voltage. But if you want to be really safe, 13.2 volts while you're developing and setting the system up is even better. And remember, the charge controller only registers the voltage to one digit after the decimal place, so it may not be too accurate, and we really don't know what the calibration status is. So setting it to 13.2 volts is what I'm going to do. So I'm going to go to setting D01, hit enter, and that's way too high. I'll just go ahead and drop it down for now to a fail-safe voltage of 13.2 volts, hit enter. D01, 13.2 volts. So that's the float voltage. This charge controller does have a lithium battery mode, and it states in the manual if you enable that mode that setting D01 is of no use. However, I don't know what they mean by that, and I'm not going to chance my batteries. So that's why I went ahead and programmed this setting. And I don't know whether I'll use the lithium battery mode on this charge controller or not. It's not clear to me in the manual what exactly that does. So I'm just going to try it out, and I'll see what happens. That's the best way to do it. Next, there's a setting called D02, and this is called the highest constant voltage for the battery. Now for that, I would actually want to change it to something a little bit higher, but look at the setting that's in there by default. I'm sure a lot of folks would just hook their lithium iron phosphate battery right up, use the default settings, and they would destroy their battery pack. It's tricky because at first everything would be going well. A lithium iron phosphate battery will charge to 14.5 volts quite readily, and they will take a tremendous amount of abuse. The problem is that once the battery shows signs of abuse and starts to have problems, it's too late. There's nothing you can do to undo the damage. In many cases, a lithium iron phosphate battery doesn't show any signs whatsoever of damage until it's too late. In my case, I really don't want to exceed 13.6 volts, but because I have not balanced the cells by hand in a very long time, it's been years, I do not run an active battery management system, I do not have a battery protection circuit, and I'm just running raw cells. I have to be very careful. So in my case, I'm going to set this voltage to something safe, which is 13.4 volts. And that will allow me to get a decent charge into the battery, test the system, hit enter, and try things out and not risk doing any damage to the battery. I know my cells are not that much out of balance, so 13.4 volts, there's almost no chance in my case that one of the cells would go too high. So I will use 13.4 volts while I'm setting things up, and I don't think I'll do any harm. The next setting is D03. Then this is I'm going to call it the low voltage cutout for the load terminals. That's what I'll call it. That's not what the manual calls it, but really that's what it is. It's a low voltage cutout, and 10 volts is a disaster on a 4-cell lithium iron phosphate battery. If you hit 10 volts, you've damaged the battery. You should never go that low. A lithium iron phosphate cell is basically empty at 3 volts. There's a lot of literature and a lot of people making claims and saying you can run them down in the 2 volt range. Well, sure, you can throw them off a cliff. You should never go below 3 volts. And if possible, you should leave some charge in the cells, and if you do that, they last a lot longer. So running them down to 10 volts is just out of the question for me. The lowest I would ever want to see a 4-cell lithium iron phosphate battery go is 12 volts, but I say that with a reserve. I really wouldn't run it down that low. So for me, my cutoff is actually going to be 12.8 volts. And that's actually 3.2 volts per cell. And no, that isn't too high. And especially if you're trying to get your batteries to last a really long time, we really don't want to run them down too far. So under a light load, 12.8 volts, once you get down to 12.8 volts, if you're running a really light load, say an amp or two, that battery should essentially be considered discharged. And keep in mind that lithium iron phosphate batteries have a much higher average voltage than lead acid. So 12.8 volts sounds really high, but it's not. It's not high at all. It's pretty much dead. So at 12.8 volts, I don't want this charge controller to run any lighting or to do anything at all. I might even set it to 12.9. The next setting is D04. And that's the lithium mode for this charge controller. Now I'm not going to enable that. To enable it, you change it to 01. I'm actually not going to use it right now. And one of the reasons why is I'm not really clear on what it does. The manual doesn't really make it clear. And it's not clear to me why this setting should be enabled or what it does, and I'm not sure I even need it. So right now I'm just going to leave it alone. I've had good success in using charge controllers like this with lithium ion batteries, and I did not need any special mode or any special treatment. I just was very careful how I programmed the voltages in, as you just saw, and I got along just fine. In fact, this very battery that I'm using now was used with a standard MPPT charge controller with no lithium settings whatsoever. The next setting is D05, and that's for the Wi-Fi password. I don't use that. I don't believe this unit has Wi-Fi, and I hope it doesn't. D06, and this is for the battery voltage calibration. And I don't have a high-end multimeter here, so I really can't verify the voltage. Also, you notice it only has 1 digit to the right of the decimal place. That's actually kind of a shame. I wish charge controllers these days would have at least 2 digits. It's really helpful when working with lithium-ion batteries because they have such a narrow scope of voltage. The voltage curve on a lithium-ion or a lithium iron phosphate battery is so narrow, it hardly changes at all, so that extra digit is really helpful if you can get it. I will be putting a better voltmeter on my battery anyway, so I'm not going to worry about it. I'm simply going to leave the setting alone. Once programming is complete, simply press Program, and it will go back to the home screen. Now this is a very good standard procedure with charge controllers. As soon as you have programmed your settings, pull the power off, let it black out, and just wait a few seconds, then reattach the power. And once it goes to the home screen, go back into program and check all your settings and make sure they're still there. Especially if you're dealing with a high-dollar lithium-ion battery pack, you better make sure the settings are there, or you could destroy your batteries. So I do remember setting 10 hours on the time. That's correct. That's the float voltage. Here we go. And that's the highest constant voltage. That's the low voltage cutout. I'm not using that setting. Not using any of these settings here. And I haven't changed the calibration setting. So yes, indeed, it saved my settings. So right now, it's nighttime, and there's no solar, so I can't test the charge controller at all. But I have programmed it, and I believe it's ready to be tested on the actual battery with a real solar panel. I will wait till it's daytime and there's plenty of sun to try it. I also want to fool around with the load terminals. I really like this idea of having a security light system attached to this charge controller. And I need security lighting, and I want it to be solar powered. So this charge controller may be a very, very good solution for me, and I'm eager to give it a try. And I will definitely record video of that when I get it set up. It's the next day, and I'm going to do some work in the solar power area here. But there isn't much solar power because it's all gray and dark out. Wind's blowing. But there's some power. So I've got my solar generators hooked up. This is a solar generator I've had in a closet for quite a while. I wasn't even using it. So I got it out, started using it. It's charging at 5 watts. This is a solar generator I modified to take the vacuum fluorescent display out of. I put an LED voltmeter inside. Seems to be working, we'll see. I just started charging it, and this display is so bright you can't read it. I'm using my little bench power supply here to charge it. It's going to about 5 watts right now. And the first solar generator I'm charging through a constant current, constant voltage power supply. Straight off my solar panels into this little circuit board here. So it's charging away. The same set of solar panels are also charging my phone here, camera phone. This USB power bank. There's the USB power board that's on the solar power equipment board. Got 2 more ports available on it if I needed to use it. It's also running that voltmeter. Keep in mind this is one pair of solar panels in parallel outside that's running all this stuff. It's also running my fan controller. And this is another inverter I have. I just swapped them out. And this is a different one. I've modified the fans in a different way. Now right now I'm just testing it all. But this is running off of solar panels, and it's doing quite well. The fans are running, it's at 22 Celsius, so it's running very, very cool. It would not be running at 22 Celsius if I didn't take over the fans, which is what I've done here. Now that's all temporary. I'll definitely make that look better after I'm done testing it. Those same 2 solar panels are also running this USB converter. This constant current power supply, which is charging this solar generator and running that meter, and running this desk lamp, which is lighting up my workbench. So these 2 solar panels are doing a lot of work, and it's amazing what a set of solar panels can do, even when the weather's dark and cloudy. It's only 2 100-watt solar panels. And today what I need to do is I need to get this lithium iron phosphate battery up and running, because it's the single largest power source I have out here. And I need to get my MPPT charge controller hooked up to this and an inverter so I can get some real light in here so I can see what I'm doing. Alright, I have some new additions to the solar power board here. These are items that I recycled from my solar powered shed, which I have shown in other videos. First up, we have a supposedly 20 amp circuit breaker. This was in the solar shed, and I'm moving all the equipment over here to the workshop. And there'll probably still be some solar equipment in the shed, but most of it's going to be here in the solar workshop. This type of circuit breaker is very cheap. I don't really know if they perform well. I don't really trust them, and so I use them more as a disconnect than anything else. I have seen them trip, so I know at least some of them must work. But you have to be careful with these kinds of circuit breakers. It's better to test them instead of just assuming that they work. But for the price, they're hard to resist. Next up, we have some pretty thick wire. And I believe this was a jumper cable This was all a long time ago. I installed this stuff in my solar shed and it's been in there a long time. I'm not going to redo any of this. You can see there's a rubber seal there. I like to have never gotten that wire in there like that with the rubber seal and everything. So I'm not going to touch it. I'm going to leave everything exactly as you see it. And I'm going to use this to connect to my charge controller I showed earlier. I don't know what kind of wire this is. It came from jumper cables. It's probably copper clad aluminum. It's probably not so great, but it will do the job for now until I can get different wire to connect my lithium iron phosphate battery. Certainly this wire will do. I'm not going to be charging at high currents. Okay, and at the other end we have some ring terminals. So again, I'm not going to touch those. I'm just going to find a way to attach them to my battery. Why mess with what works? These are well done. They're heat shrinked. I'm not going to mess with them. Powering the charge controller in the solar shed was this circuit breaker. So now I have an additional circuit breaker and I will be using this absolutely. So I'm glad to have all this stuff. The next step is to get the charge controller on the board. So I'm going to pan the camera up. So I think somewhere right about there will do the job. I always mount my charge controllers really low on the board, like down here. It'd be nice to have them up high at eye level. The reason I mount my charge controller so low is because you want the shortest possible length of wires between the charge controller and the battery. Now for the short term, I'm reusing wires that I already have, and they're about 3 foot long. And that's okay, it's just a temporary setup. Eventually I'm going to replace these wires with probably very thick, short wires. I don't know what gauge, whatever I can get. This leads into the reason why I built this so-called workbench / battery shelf. It keeps the batteries up off the ground. So these solar generators are not really a good example. But over here, I have my lithium iron battery, lithium iron phosphate, right here. And that's the type of batteries I use now. And so any additional batteries I add to the solar workshop are going to be this type. But having a shelf like this, it allows you to get a workbench. Of course you can use it as a workbench, but it also gets the batteries up off the ground and it gets them very close to the charge controller. So by getting your batteries up near the charge controller, lowering the charge controller as low as you can on the board, and using the shortest possible wires, this ensures that you will have the minimum voltage drop over the charge cables that are feeding into the battery from the charge controller. These details are often overlooked in solar installs, and I'm referring to larger solar installs, but even the small ones, like this. And usually lead acid batteries are too heavy to lift up off the ground. If you have a very large lead acid battery bank, the last thing you'd want to do is stick them up on a workbench with plastic legs. But since I'm using lithium ion batteries only here, probably won't have many lead acid batteries. Weight is not a problem. This workbench can handle a couple 100 pounds easily. I'm going to mount the charge controller right here, and the battery bank will be in this area more or less, and I may move these things around. That will allow me to get really short wires when I'm ready to and reduce the voltage drop as much as possible. Before I get all the batteries and wires and so forth installed, I decided to go ahead and build another solar power board to put over here in the corner up against the wall. I have two 2x4s that I cut and trimmed from my shed that was knocked down. They're a bit splintered and beat up, but they'll do. There's also a piece of 1/2-inch plywood which I found, and I trimmed that up, and it's about 3 foot wide. That will give me a lot more room to mount my electronics without having to worry about running out of space. This is very simple to build, and there's already a video of a power board being built. So I'm not going to record the construction. It's just simply 2 posts, a board, and some reinforcement behind it. It's kind of like a billboard or a sign. It's very simple and it's very easy to create, and it allows me to pick the board up and move it around if I want to. It stands on its own 2 legs, and it just needs to be attached to the wall wherever it's standing. And if I ever move or go anywhere, I can just take the screw out of the wall, pick it up, throw it in a vehicle, and transport it to the new location. Okay, I just got done building the power board. I used wood that I had available. It's a little bit smaller than the other one, but it will give me the extra space I need to mount all this equipment, and also for future expansion. The power board in position. I have the option of adding some additional material at the bottom if I want to. Probably batteries will be in that area, but if I need to, I can take another strip of plywood or a piece of 2x6 or anything really, and just bridge across that gap and bring the height of it down. So I have that option for later on. I do need to put a metal bracket to anchor the power board to the studs, but it's behind my workbench and that's holding it there, so it's safe for the time being. Next, I'm going to mount the Make Sky Blue charge controller and move my lithium iron phosphate battery over there and get that running so I can get some power in the solar workshop. I went ahead and added another piece of plywood at the bottom. I found a piece that fit and I had to trim a little bit off the side, and that way I have a little bit of extra room to mount electronics. I've placed the lithium iron phosphate battery pretty much where I think it's going to go, and now I can mount the charge controller probably right above it. I also have a pure sine inverter, which I've had in storage for some time. It's a small one, but I'm going to get that and mount that as well near the battery, so I'll have good strong AC power if I need it.